before natin i-discuss, no? Before natin himay-himayin yung unang example na pinakita ko sa inyo. So the reaction between ethylene or ethene and hydrobromic acid, before ko yun i-demonstrate sa inyo later, gusto ko munang i-introduce kayo to the concept of bond formation and bond cleavage or breaking. So cleavage means binibreak ninyo, pinaghihiwalay ninyo, or hinahati ninyo yung bond, because these are the elementary steps involved in chemical transformation. So kailangan naiintindihan po natin kailan ba nagpo-form ng bond ang dalawang atom. Kailan ba nagbe-break yung bond sa dalawang atom. And ito, gagawin ko, i-present ko po sa inyo ito sa pinaka-relatable na lengguwahe. We'll actually come up with a lot of real-life analogies for this. Okay. But before we actually deal with bond breaking and bond formation, kailangan naiintindihan muna natin what is a bond. So in organic chemistry po, more particularly, the focus is a covalent bond. So a covalent bond is a bond that forms between two atoms that are sharing a pair of electrons. So dito po, sa ating drawing dito, there's a covalent bond between fragments or atoms A and B. And so this is what we call, or this is what Professor Dindy Voiles alluded to earlier as your sigma bond. So yung single bond na yan, we call that a sigma bond. And that sigma bond is also a covalent bond, and that is comprised of a pair of electrons. So one pair of electrons being shared by elements or by atoms A and B. So again, kailangan po basics of ano ba yung definition ng bond. Dapat naiintindihan ng ating mga estudyante yan. And then Professor Dindy earlier as well mentioned about pi bonding. So this can become a double bond. So when we say double bond, the first bond is a sigma bond, the second bond is a pi bond. So pinakita po niya yung kanina. And then I'll talk about that again like later on, like in the example. Okay, so ang sabi natin kanina, we'll talk about the fundamentals of bond formation and bond breaking or cleavage. So ang una muna po natin i-cover is bond formation. So paano ba nagpo-form ang bond between two atoms? So there are two different ways by which a covalent bond can form. So the first of which is what we call a homogenic mechanism. So in the homogenic mechanism of covalent bond formation, what happens is that each of the atoms participating in the covalent bond will actually contribute one electron. So ito po yun. So atom A has an unpaired electron, and then atom B has an unpaired electron. So kung baga po sa group project, kung ang binigay na assignment ng teacher ay, okay, student 1 and student 2, mag-form kayo ng bond. Gumawa kayo ng project together, ang expectation ng guru dyan ay equal participation. So ito pong homogenic, ganun po yun. So yung ambag ni B ay equal sa ambag ni A. Pag nag-form sila ng bond or kapag gumawa sila ng project, eh di ano yun, patas yung group work, ano po, kasi pareha silang nag-contribute. So that is what we call a homogenic mechanism for the formation of a covalent bond. Okay, and typically, when it comes to organic reaction mechanism, so nakita niyo siguro sa example si Professor Dindy kanina, she was using arrows to demonstrate, the formation of bonds or the breaking of bonds. So when it comes to homogenic bond formation, i-represent natin yung flow, your movement ng electrons using a fishhook arrow. So isa lang, kung makikita nyo, yung hook niya is isa lang. So kapag nakita nyo po yan sa organic reaction mechanisms na nakadraw sa textbook, ibig sabihin yan, you're actually moving one electron or an unpaired electron. So in this case, there's a fishhook originating from B going into this region where A and B will form a bond. Ganon din po yun. Yung A, it has an unpaired electron. So therefore, yung fishhook rin will represent the movement of its electrons. So when those electrons, or essentially the orbitals where those electrons are present when they overlap, that results in the formation of a covalent bond. So again, tandaan nyo po yan, fishhook. That's how you represent single electrons moving during an organic reaction mechanism. So yan po yung papakatandaan po natin. And we call each of these species which has an unpaired electron, it's called a radical. So this is like a radical type mechanism for covalent bond formation. Okay. Next naman po. So kung kanina, homogenic mechanism, this time naman, we have this mechanism called heterogenic bond formation. So this time around naman, ito yung mas madalas siguro na-experience ng mga estudyante at mga guro sa klase. No? Kapag nag-assign ng project ang teacher, okay, go group into partners, student A and B, magagawa kayo ng project. Minsan, natsyempohan, ang isang estudyante ay tamad, walang ambag. Yung isa naman, sobrang bibo or maraming resource, additional lang yung gagawa. But then at the same time, minsan yung mga estudyante naman na mga bibo, wala naman din po masyadong pakialam. So they're willing to share their electrons. So in a heterogenic mechanism for bond formation, the electron pair will only come from one source or from one atom or from one fragment. So this time around, B yung atin pong source ng electron pair. Tumatanggap lang si atom A, and that's how they form a bond. And whenever we and then this time around, since hindi po equal yung kanilang yung kanilang pag-share ng electron, kasi yun ang gagaling lang kay bilat ng electrons, si A tumatanggap lang siya. So we actually have terms for these species. So nabanggit rin na Professor Dindy kanina, yung ating mga chemical species, whether it be an atom or a fragment, that is electron rich and that is acting as the donor of electron, we actually call that a nucleophile. So when we say nucleophile, it is looking for a nucleus with which it will share its electrons. Pagdating naman po dun sa element A, it is electron poor. So it prefers to accept electrons. And so since it's an electron acceptor, we call it an electrophile. So kapag po meron kayong ganong estudyante sa klase na yung isa hindi gumagawa ng kanyang ambag at yung isa naman po ay overperforming, at yun po, pwede nyo tawagin nucleophile yung isa po electrophile. So ganyan niya po i-brand ng inyong mga estudyante. No? So, and then we typically represent the movement of electrons during the heterogenic mechanism for bond formation in this manner. So yung pong ating regular arrow, yung double hooked arrow, so since dalawa na yung hook niya, that represents a pair of electron moving. So this time around, yung pong ating electrons is a pair of electrons is originating from B and is being shared with atom or fragment A. So yan po yung heterogenic mechanism for bond formation. So kung mapapansin nyo, yung end result is just the same. So pero nagkaiba po yung mechanism by which electrons are actually shared to form a bond. Okay po ba? All right. So kung meron po tayong bond formation, sabi ko kanina, meron rin naman tayong bond breaking or bond cleavage. So, again, babalik tayo dun sa fundamental understanding natin that, a single bond between atoms A and B that is comprised of a pair of electrons. So, lagi pag nakita kayo ng isang guhit between two elements, that is actually corresponding to a pair of electrons or two electrons. So, kaparehas ng mechanism kanina, kung merong homogenic, meron namang homolytic. So this time around, what happens is that when you break the bond between atoms A and B, equal yung pag-split ng electron pair. So isang electron ends up with A, isang electron ends up with B. So kung ang analogy po dito, kung dalawa yung anak, kung kayo po ay magulang at meron kayong dalawang anak at nag-uwi kayo ng pagkain, dito na po papasok yung term na hating kapatid. So equal po yung pag-split ng electron pair between the two atoms or two elements. So ganun po siya. But then ang result po niyan, gaya ng pagkakahat ng sinabi namin kanina, ay dalawang radicals. Kasi if you're gonna represent the splitting of the electron pair, in this particular example, is such that you're gonna use two fish hooks originating from the bond, and then yung tip po nun, or yung hook, is actually pointing to the receiving atom. So atom A and atom B. So forming two radicals. So yan po ang homolytic bond cleavage. Okay, ito naman po ang heterolytic cleavage. So starting from a single bond between atoms A and B, what happens is that yun pong buong electron pair ay napupunta lang sa isang to only one of the two atoms participating in the covalent bonding. So dito na po papasok kung kumbaga kung may dalawa kayong anak, binigyan nyo ng pagkain, dito na po yung medyo may pagkaswapang yung isa, yung pagka-selfish, yung isa po naaagawan. So yun po yung mechanism of heterolytic bond breaking. So dito naman po, I would just like to point out a couple of things as well. So B gets the entire electron pair. And if you're going to represent the movement of electrons during the breaking of the bond between A and B, this is how you are actually writing this. So originating from the single bond, you're actually going to direct the arrowhead to B. So ang result po nito is yung A, wala siyang nakuhang electron from that bond, and then it entirely ended up doon sa B. So hindi ko po to nilagyan ng ng charges, no, kasi these are just like more generic representations. But then later on makikita na ninyo na since hindi po balanse yung pagka-split ng electrons between the two atoms, heterolytic bond cleavage usually results in the formation of it results in a formal charge or in the changes in the overall charge of these atoms. So as early as like in those demonstrations po, I have actually shown that arrows can be used to indicate or to demonstrate the movement of electrons during a chemical transformation. So yung sinabi ko nga po kanina, if the splitting of a bond or if the formation of a bond involves one electron, like from each participating atom, then we call that a radical process. So either you're starting with radicals to form the bond or you break the bond to form radicals. Yun po ang radical processes that we are actually talking about. So again, homolytic and homogenic bond formation and breaking are actually what we use as descriptors for those steps. And then, when it comes to, kapag nakakita po kayo ng reaction mechanisms with the typical double-hooked arrow, dun nyo po matatawag that these are actually polar processes where the electrons actually move in pair. So dalawang electrons po lagi yun nire-represent ng traditional arrows. So again, heterolytic bond breaking and then heterogenic bond formation. So yun po. Keep that in mind, students and teachers. Malaki po ang pinagkaiba niyan kapag wag niyo po yung i-interchange kasi pag ipinakita niyo po yung reaction mechanism niyo sa mga chemists, iba po yung interpretation nila kasi these are conventions, these are actually standard ways by which we represent the movement of electrons during to represent a reaction mechanism. And then meron pa rin po yung mga certain intricacies that you have to watch out for. So the tail of each arrow should be pointed at the source of the electron. Ganun po yun. Kung saan po nanggagaling yung electron, dun po dapat nakapoint yung buntot ng inyong arrowhead. And then, the arrowhead, yun po mga hooks ninyo, these should actually point to the receiver or to the acceptor of the electron. So yung arrowhead, lagi yung nakapoint or nakaturo sa electrophile. Yung buntot po, laging nakaturo sa nucleophile. So, hindi po yan interchangeable. So, ito po yung mga usual rin na mga causes for mistakes po ng students whenever they write a reaction mechanism. So, minsan po, yung electron acceptor, parang sa kanya nanggagaling yung arrow. So, again, you're representing the movement of electron. So, kung saan nanggaling yung electron, nandun po dapat yung buntot. Kung sino yung tatanggap, dapat nandun yung arrowhead. Okay, so simple lang naman po yung mga yan. But then again, like all of these, basic ways by which we represent structures during reaction mechanisms and arrows and movements of electrons, kapag pinagsama-sama nyo na po yan, baka malito po kayo. Kaya it's very important that you keep all these foundation knowledge with you whenever you are writing up an organic reaction mechanism.